Hello, everyone. My name is Niaz Ahmed. I'm an associate professor in the Department of Electrical Engineering at FAST National University of Computer and Emerging Sciences. And this is my pleasure to participate in this third international conference on materials chemistry and environmental engineering. My topic of today's presentation is Oceanography and Informatics. Let's start with a brief introduction of mine, and then I will go lead you towards my presentation. Okay, so what are my research interests? Just quickly going through this. So I basically work in the underwater wireless sensor networks, and when you talk about underwater wireless sensor networks, so there's a huge field. You get to have those monitoring informations and kind of communication applications all over there. There are different mode of communications being there. We will be quickly looking into them during this presentation, but briefly I could share with you that there is acoustic, there's magnetic resonance or induction, and we have optics communication. So mainly my research work surrounds around magnetic resonance and induction, which I will be talking you in this presentation. Some of my contributions to my research is basically, so if you, there are some of the research papers being flashed out, and you probably could see different work of our group towards magnetic inductive communication in underwater wireless sensor networks, and you can see these different few here these sensor nodes we have developed in our lab, and we have these different kinds of applications basically being done using our low power magnitude inductive. And here is another one for the structural health monitoring of underwater. So there are all these different works we probably are doing for the last few years, mainly dealing with underwater wireless sensor networks and responsible for magnetic inductive communication. This is one of my book recently published in underwater communication and networks. Probably free available on the website to get downloaded. Here are the list of the few sensor nodes we have designed in our lab. This is a sensor node basically can communicate underwater with different sensors capabilities. This is a different version of those different sensors. We have some advanced version of coils being used for this communication, and over the years we have built on this to make our systems more robust. Some of the experiments setups here. So anyway, I'll just quickly skip this part and let's move to the topics of today's presentation. So basically, what we are planning to do is let you know about the underwater world, the potential underwater has, the communications and the applications it can offer, and then the different modes of wireless communication probably you can use there to have your applications then. Talking about the underwater world, so just imagine that the land we are living in is only 29% of the Earth proportion. You have 70% of the proportion is as water. So just imagine that these 29% of the land we are living have tons and tons of applications around us. So how big is this ocean and how big is this water thing? So that really is something to think for. So what this 70% is, basically there are different water bodies, the form of streams, lakes, canals, or rivers, and sea and oceans. So all of these sum up to the 70% of the land or the earth. So 30% is probably the land, and we have this 70%. So usually when we talk about applications or communications with wireless sensor networks, so that probably can have all those streams like canals. But when we talk about going big, so it basically has this river and oceans, which is the scope of our today's presentation. Now, before I jump into these technical details of how this communication works, let's just quickly go through this video, which will let you know that how deep is this ocean. Uh, this is downloaded from the YouTube, the BuzzFeed, and this basically let us know that how deep is this underwater. oceans. So this is the surface of the water, and going deep like 40 meters, that's the deep a scuba diver can dive in there. And then if you further go down deep over there, and you will just go deep and deep, and this 300 meter, and 300-meter is the height of the Eiffel Tower. So that probably gives you an idea that how deep this is going to be. And this is a 500-meter where a whale can dive, a whale, sorry, a whale can dive there. And then you go on deeper and deeper and deeper, and then you have 1 kilometer. And that's the maximum depth sunlight can reach. Way minimal, but that where you can still have some kind of energy being there. And there is like about 2 kilometers, which is the Grand Canyon lowest point. Just go further deeper and deeper and deeper, and this is the average depth of 4 kilometer. Wow, imagine 4 kilometer is too much. And this is something you are going deeper and deeper. Just imagine if you are lost somewhere in the oceans and what's going to us. Think about Titanic and those stuff. So that's probably the height of the Mount Everest. Wow, wow, that's quite deep. 8 kilometers, and then if you further go down and deeper, and then you will have the Mariana Trench, uh, where basically you can have the deepest point on the oceans being recorded. So this is depth where John Wash went, and this is the Mariana Trench, 11 kilometers. So that's huge. So this probably gives you an idea of how deep this ocean is and how deep is the core of this. Here's credits to this video. Uh, so because this is not prepared by me, so it's important to give credits. So the questions here comes that how deep is this? We know about how deep is underwater. So how what does this underwater world offer to us? And we know that if this is this much deep, so there will be tons and tons of applications and challenges being done. So let's just quickly go through those different challenges and different applications that this underwater can offer to us. The first thing that pops up to your mind is marine wildlife, where basically you have all those different kinds of marine life, different animals, and you probably will be able to see them in the natural geography, national geography, or those wildlife documentaries being watched all over the world. You see those different beautiful nature of the world lying underwater. You have these different kinds of animals, plants, uh, and things living. There's a whole new world living underwater. So monitoring that underwater world, and then you probably can have to have how to use that or exploit that potential. So that's some of the applications we can have in ocean. Then some of like the structural health monitoring stuff, where you have different dams, you have levees and different stuff. You probably would like to have your structures built in underwater, and you would like to have them monitored and see if everything is perfectly there, because it's usually not easy to go underwater and check those different kinds of stuff. So you need to have some kind of sensor networks or applications that probably give you readings where you can talk on that and discuss that what's going to be have the effect. And then there's a lot of different minerals all over there, and the oil and gas is what billion dollar industry. Fisheries industry, I mean, everyone knows of this, and well, all seafoods coming from there. So the fish industry and those different kinds of applications that you have there, and the internet cables. You probably most often you probably would have heard those news where some shark or some other wildlife comes and cut those cables, and you're disconnected from the whole world. So that probably is some area of to monitor there and get into the applications. So you have like these lot of tens of applications over there, where you probably not limited to these only, but just some of the significant or the important applications. I just, therefore I wanted to share with you. And then we have military applications. So talking about military applications, and you have all those different kinds of stuff over there, where you probably go there and have your navy or marine train over them, and then to have strengthen your defense. And then in terms of exploration, you have all those AUVs, UUVs, robotics, and crawlers who probably have different sensors installed on them, and they some of them are went on the surface, and some of them go through deeper into the water, and they probably give you different things of mode of information. Here's some other pictures of the marine exploration. Basically, this is the data being taken from the Java Deep Sea Biodiversity Expedition happened in 2017 and 2018. You probably can see it all in the map, where different kinds of sensors being installed in these different areas, and they probably are collecting different kinds of information all over the year. And then by the end of the year, they can share all those data and information with the rest of the world. For the oil exploration monitoring, we have these different equipments, communication equipment, which are used to monitor the environmental parameters of this offshore oil platforms, where the vibrations, the postures, and stress monitorings of the pipelines are happen remotely or while with help of different sensors. In the structural health monitoring, we have these bridge scarring usually occurs. So because this water is there and this is scarring the pillars of the bridge with time, and eventually like about 10 or 15 years. So one of the survey that basically reported that in US about 40% of the bridge failure was due to the bridge scarring, so which is a significant number. And then Department of Transportation basically funded us different projects to work on these scarring monitoring. And similar to bridge scarring, we have this levee monitoring, where we have those levee walls being able to break down, and then that water probably can affect the rest of the area. So these are all those different kinds of applications which are present there, and which allow each one of us to put more effort and more contribution to the underwater research and to some kinds of communication. This is one of the Tarpela dams, basically in Pakistan, which is one of the largest dams in Pakistan and probably in Asia, which basically with time have been filled up with different sediments, and those sediments filling and monitoring is one of the major challenge in generating the electricity, because the capacity is declining every year. So that's a challenge for the people here to lessen those things and monitor the sediments and do some sediment profiling, and then probably provide some solution to get rid of these sediments. So we have all those different kinds of applications, starting from military to commercial monitoring, and eventually we have some hobbyists where they have scuba diving, and they use some equipments to go underwater and then communicate with each other. Um, the idea was to give you an idea of like how deep this ocean is and what is the maximum potential this underwater world offer. And probably I'm sure that most of you will be listening to this slide, will getting an idea that what are the tons of different applications that probably are being able to go from this underwater world. This is the environmental monitoring. You probably have heard of those different tsunami warnings being raised every now and then, where they monitor the tidal waves in water, and then they detect the tsunamis, and they give signals to back there on the coastal areas that okay, there's a waves coming on, and then you probably have to do something to alert your community or population to leave those coastal areas. Similarly, we have those oil and gas leakages or seepages in water, which can be dangerous at times for the shipping and those things which basically go in underwater. So monitoring and then uh, raising those alarms, this is really important. So talking about different applications, we have all these different applications, and the potentials of research efforts is required significantly to work in these oceans and waters. So all it's dealing with informatics and information of exchange of information from one place to another. There's another view of those tsunami warning system where basically they have those different sensors installed at different depths, and then they probably give you the signal back to the buoy, and then it's translated to the satellite, and the satellite can then give it back to the radars from the coastal areas. Here's another one, basically DART system. It's an acoustical link that transmits data on bottom pressure sensor surface buoy, and then satellite links relay the data to tsunami warning centers, giving them off for fastest real-time data about tsunamis that could potentially impact coastal areas, somewhat similar to what we have seen in the last slide. There are those different DART locations where they have installed those different sensors to monitor the surface pressure, and then they probably give you the warning about the tsunamis. Here's another system of deployable autonomous distributed systems, where on the coastal area you can see probably that those underwater acoustic communication happens, and these systems work in the depth of 300 meters, and the range is about like 2 to 5 kilometers. You get all those different kinds of information from this, and these are different telemetry devices. You probably can Google them and get to know about all those different kinds of potential and applications and the equipments that is being spread over there. Here's another one where the littoral monitoring is being done in underwater. Some of the stuff designed or already deployed in the United States. Here is the underwater acoustic communication network. We basically have a C-Web, which is a network of the United States that combines these submarines by node with the mobile autonomous underwater vehicles or unmanned underwater vehicles to monitor oceans and then submarines and from activities. So this drills down us to get to know that what is the future of the underwater world. So I am here teaching this, and I'm going to play this video for you, which is a quick short video that can give us to know that this underwater world is where it is leading, and you probably can know that what you can anticipate in the near future years. You're going to have underwater cities built. You're going to have those markets built there. Your residence is going to shift underwater. Your farming is going to shift underwater. Here's a concept being displayed in this video, and you probably can see everything going underwater. So the more this world is going underwater, the more applications is going to be offered, and then probably you have this different step. Wow, yeah. So you probably can read subtitles over here, which tells you how this is one of the word underwater over there. You can build millions and of such setups over there, because as we discussed in the start, that underwater is, so water is like 70% of this earth. So you can build islands over there of your own, and that probably is a huge potential, which in the future years everyone is going to see. So we are talking about going to Mars, but I think if you, instead of going to Mars, if you go underwater, that probably brings you another world, and that's something to ponder over. So this is different applications perspective, which I wanted to give each one of you, so that you get an idea that how important is this underwater and oceanography and oceans, and then what is the role of this informatics and communication in these oceans. Because when you have those different applications, so you have to have communicate between different items, species, or modes or sensor nodes. And so let's just quickly go through these different modes of underwater wireless communication. So what of different communications are offered. So when we talk about communication, so we have those terrestrial communication, we have indoor communication, we have underground, and we have underwater, which is basically the scope of our today's presentation. And then so these are the different mediums of communication: air, into underground, underwater. And then you have those different modes of communication on the right side of this picture, which basically are EM waves, electromagnetic waves. And then we have sound waves, we have or otherwise they are called acoustic waves. And then we have optics or light waves, and we have magnetic fields. So when we basically have this underwater wireless communication, so you can have these different, this graph gives you an idea of how uh, the distribution is, that if you are going to use EM waves, so you are going to have extremely short distances, uh, but you have decent number of data rate. Similarly, if you have optic communication, so optic, you get to have a very decent data rate, but the distance is extreme short. So usually that's why you usually see there's conventional mode of communication, or there is being used is acoustic, which gives you a range of about 100 kilometers, which is something huge. But the data rates, on the other hand, is too low. So which gives all limits all the advancements in those applications. And you talk about the MI communications, that's principally a reasonable mode of communication, which gives you reasonable bandwidth and data rate and a reasonable distance. And that's probably my area of research over there, where we usually go and work on this. So it's something important to know. Anyway, talking about the advantages and limitations of each one of them. So we have acoustic communication, which basically has advantage of long range transmissions. But the trade-off, again, as I mentioned in the previous slides, is the data rate. So the limitations are basically the propagation delay, because you have a way uh, uh, I mean, the acoustic speed basically is very low as compared to the RF. So you have like 1500 meter per second. If you compare this with the EM wave, which is like 300 millions meter per second, which is huge, or very high speed. Compared to that, this is like million times slower communication being happen. And then the bandwidth is quite low, and a lot of physical layer challenges as multipath and Doppler spread. But it's being explored and worked and contributed in a lot of those different areas, and different modems being designed, and a lot of contribution has been done in this field already. Therefore, we can see that those different kind of modems and equipments being done all over the world. Uh, Talking about optical communications, so again, the advantage is very high data transmission rate, very high transmission, and the delays are extremely negligible, way less. But the limitations we get, on the other hand, are the severe absorption of light energy in water, which basically limits the transmission range to extremely short range, and that probably limits the applications to very few applications, because otherwise you have to have long range communication. But the major players, if you can see, there are Sonar Time, Q-Com, Huawei, modems. And then comes the MI communication, which basically we work in our research lab also, and being successfully tested in our water and air and lakes and seas. And so the advantage is that it works very well in all those different mediums being previously discussed. In air, underwater, and underground, there's no multipath, there's no Doppler, there's no physical layer problems associated with this. The delay is no, like usually we talk that there's negligible delay, but like you can probably literally mention that there's no delay at all. This instant communication happens. The low, it's very low cost, like less than $10. It costs you to build all these sensor nodes and this coin. The limitations are basically strong signal attenuation or high frequency, so you probably are limited to low frequencies, and then you have those directionality issues basically. So you need to have those coils aligned with each other all the time, otherwise you get some robustness in your communication. And talking about the different players in MI communications. So our group, we started this in Missouri University when during my PhD in 2013, and then in Harvard University, and now in FAST University. Basically, we are working on this MI communication. There are different other professors working on this these years. So this basically sums up all this presentation. I would like to give my acknowledgments where because different pictures and videos are being taken, and some of them are cited, some of them are not cited. So it's very important to give them acknowledgement. So this is something from my side, which I wanted to share with all of you. That how deep is this ocean and underwater world is, and what are the different kinds of applications that are being there, and that's probably it requires us to have think over and then jump into this field and contribute to this underwater community and build a lot of different setups and informatic workshops, and this conference I believe can help us to spread the word and convince some of you to probably contribute and to work in this area. So it was nice to be here, and I would like to thank you all. If there are any questions, they are welcome, and I will be here to respond to them. Thank you.